Hello. In this video, we're going to look at factoring all types of quadratic expressions. So question 1, factor 12x squared minus 10x minus 8. When we're factoring quadratic expressions, we always want to look for common factoring first. Okay, so that's the first thing I'm going to do here is between these three terms, what's in common? Well, I see a common factor of 2 in all three terms. There's no variable part in common because this last term does not have a variable piece attached to it. So I have a common factor of 2, and if I divide each term by 2, I get 6x squared minus 5x minus 4. And what's remaining in the brackets is a complex trinomial. So we can use our methods of factoring complex trinomials for this. So if we apply the method of decomposition, that means that we are going to be looking for two numbers that multiply to equal 6 times negative 4, which is negative 24. And those same two numbers have to add to give us negative 5. Okay? So if we use negative 8 and 3, that should work for both statements. So we're going to split apart that negative 5x with a negative 8x and a 3x. So I keep that common factor of 2 here, and I'm going to rewrite this complex trinomial where I replace the middle term with negative 8x and positive 3x. Okay, so now next step in decomposition is to find a common factor in the first two terms and a common factor in the last two terms. Again, keeping this overall common factor of 2 in front. So a common factor from the first two terms, I've got 2x, and that leaves me with 3x minus 4. And the last two terms don't really have a common factor, but for the purpose of decomposition, we take out a common factor of 1, which means we're simply left with 3x minus 4. So now we see that factor of 3x minus 4 showing up in both terms inside this big set of brackets. So we're going to take out that 3x minus 4 as a common factor, and we're left with a 2x plus 1. So that's our factored form. Okay, on to number 2. Factor negative t squared plus 49. Okay, again, we're going to look for common factors first. Well, here I don't necessarily notice a common factor, but we do know that when that first term in the expanded form is negative, we tend to take out a common factor of negative 1. So I can write negative or negative 1 in front of the bracket, and that leaves me with, if I divide both terms by negative 1, I get t squared minus 49. Okay, so again, that's a general convention that when that first term in the expanded form is negative, we take out a common factor that is negative. In this case, negative 1, because there is no other numerical common factor other than 1. So now what's left in the brackets is a difference of squares. I can rewrite this as t squared minus 7 squared. So it's something squared minus something squared. And we know that a difference of squares factors as the t goes in the front part of each set of brackets. The 7 goes at the end of each set of brackets. And in the factored form, one of these binomials has a positive sign and one of these binomials has a negative sign. So this is our fully factored form for number 2. For number 3, factor 3x squared minus 30x plus 75. Again, I'm going to look for common factors first. It's very important. It makes the rest of your work easier to factor. So I see here that all of these terms have a common factor of 3. So if I divide each term by that common factor of 3, I'm left with x squared minus 10x plus 25. Okay. So here, this is a simple trinomial. So to factor a simple trinomial, I want two numbers that will multiply to give me 25. And the same two numbers have to add to give me negative 10. Okay, so in this case, those numbers are negative 5 times negative 5 will multiply to positive 25. And negative 5 plus negative 5 equals negative 10. So I keep that common factor of 3 in front, and then the factored form of this simple trinomial is x, and I'm going to use this first number, minus 5, times x, and then we use the second number, minus 5. Because those two binomials are exactly the same in this case, we usually write that factored form as 3 times x minus 5 squared, because that's what it means to have that binomial multiplied by itself. It's x minus 5 squared. So there's our fully factored form for number 3.